All right. Well, welcome to the last lesson for this week. Honors Algebra 2. This is going to be 11.4. We're going to finish up by talking about what are called measures of center and spread. We've already talked about quite a few of these. We're just going to talk mostly about notation and then talk about this idea of what's called a resistant measure. Uh, so to start off with, let's just talk about notation. So I've got this kind of chart to help us out with that. We've got means over here on the left, standard deviation on the right. So when you're talking about the parameters, so when you're talking about the mean of a population, so remember parameters are for populations, statistics are for samples. So the mean for a population, we use this lowercase Greek letter mu. So mu, that is our symbol for population mean. So the symbol for a sample mean is what's called x bar. So it's this x with a bar at the top of it, and then it's read as x bar. For standard deviation, we've got some slightly different symbols. We've got this lowercase Greek letter for sigma, so that is for your population standard deviation. And then we've also got this S sub x, which is read S sub x, which is your symbol for the sample standard deviation. For today, we're going to be focused on these two right here, just because most of the time, we talked about this in that first section, we don't have data for a population. So when we're looking at data just for a sample, we're going to focus on the two at the bottom here. So we're going to focus on x bar and on S sub x. Okay, so the list of numbers below in example 1 shows the scores on the first Honors Algebra 2 test for the one class period that I picked. Most students did very well, so you've got your scores there. Let's find both the mean and the median of our data set. So let's go stat, edit, and let's put all those in. Just for the sake of time, you'll notice that list 1, I've already got those typed in for us. So 64, 73, 78, and so on. So if you need to, pause the video, get those typed in, and then you can continue watching. All right, so to find the mean and median, we're going to go back into stat, over to calc. We're going to choose that first option for one var stats. Make sure it says list 1. If you need to change it back to list 1, just hit second 1 for list 1. If it popped up on the home screen, then you don't need to type anything. Otherwise, yeah, just make sure list 1 and let's hit calculate. So it tells us that our mean for our data, we're looking for x bar, tells us that the mean is 85.13. Hey, that's pretty nice. That's kind of a nice way of finding the mean, so you don't have to add all those up and then divide by how many there are. Kind of a nice little short way of getting there. And then remember the median is also in this same list. So median is down here. It tells us the median is 86. For median, we really don't have any sort of special way of writing the median. We usually just abbreviate it the same way you see it on your calculator, which is that it's equal to 86. So MED equals 86. Okay, now unfortunately, there were 3 students that missed the day of the test. And so in Skyward, their grade went in as a 0. So in the grade book, the data really looked like this. You had a lot of really good scores, but these 3 scores of 0. So let's figure out what would be the effect of those on both the mean and the median. So let's go back into stat. Let's choose edit once again. Let's go down to the bottom of list 1. So after the last value of 97, we're going to put in 0 3 times. There's 1, 2, and 3. And now let's go back to stat. Let's go over to calc and let's run one var stats one more time. And okay, so our mean dropped off quite a bit. Remember our mean on the first part was 85.13. Now our mean is like 15% lower, just about 70.94 with the 4 repeating. How about for our median though? So our mean dropped off quite a bit. For median, we actually have a median of 85.5. Wow. Now, it did get a little bit lower, but when you compare the two, the mean definitely got affected much more. You're talking about a difference of 15 points, whereas median, you're talking about a difference of less than 1 point. You're looking at half a point difference. So that brings up kind of a big idea of what we're talking about today, which is that the values in the data set that are too large or too small, we've already talked about these. Those are referred to as outliers. So that would have been the zeros from that previous example. We said that the median is resistant to extreme values or outliers. So explain what you think that means with referencing the example above. Here's what I'm looking for. The mean is a better measure of center to use when the data has no outliers. So if the data doesn't have outliers, go ahead and use the mean, but the median is going to be the better measure of center to use when the data does have outliers. So if, in this case, because that second part, there were outliers, then the median would probably be a better one to use. It would probably more accurately reflect how the students did. When you think about the mean of 70.94, that goes right here. That's really not a very good idea of how well the students did because only 4 students did worse than 70.94. 85.5 would still be kind of towards the middle of all the data, even with the 3 outliers in there. So that's where median is probably a little bit better. Okay, let's look at another example. And in fact, I think this is the last example for today. Pretty short day here for this last one. So you're going to go buy a car at CarMax, and to help you make a decision, you wrote down the fuel economy of 11 cars. So you've got everything from 22, let's see, 15 at the smallest, up to probably a Prius, 52 miles per gallon. So let's find the mean and median, as well as standard deviation and interquartile range, and let's decide if there's any outliers, and if so, what they are. So let's do that now. So stat, let's go to edit. If you want to put them into list 1, you can. I just have them over here on list 2, so that'll work out okay. And then let's go ahead and calculate all those values. So let's go back into stat, over to calc. We're going to do 1var stats. If you put yours in the list 1, you can leave it. I changed mine to list 2, so I'm typing in second 2 for list 2. If yours is on the home screen, you do the same thing. You just type in list 2 after where it says 1var stats. And let's go ahead and hit calculate. Let's get all this information. Okay, so the mean for all of this was 28.82. Let's see, our median, I'm going to scroll down a little bit for that one. Median was right at 25. And then we're looking for 2 more things. We're looking for standard deviation. Remember, standard deviation is abbreviated as S sub x, which is actually the top of this screen how I have it right now. Let's just go to the nearest hundredths place to 9.73. And interquartile range, we'll take Q3 minus Q1. So that would be 35 minus 24 is 11. Okay. So now what we need to decide is, were there any outliers that would affect our results? Because if there are, remember, we probably want to choose either the median or the mean depending on those outliers. So let's use what we talked about in the previous section. Let's go ahead and find those outliers using that 1.5 IQR rule. So 1.5 IQR rule, let's find our lower and upper bounds. For lower, we'll take Q1, which is 24, minus 1.5 multiplied by our interquartile range of 11. So that's 24 minus 16.5 is 7.5. So that's our lowest acceptable value. And then we'll take 24 plus 1.5 multiplied by 11. So that's going to be, well, actually, hold on. Q3 was 35, wasn't it? Let me fix that real quick. So Q3 was 35 plus 1.5 multiplied by 11. So that becomes 35 plus 16.5 is going to end up being 51.5. Okay, so 7.5 is the lowest. We don't have anything lower than that. 51.5 is the highest. We actually do have something larger than that. The 52 was an outlier. So yes, 52 is an outlier. So what we just talked about, what's affected by outliers, we said the mean was affected by outliers. So what would be the better measure of center? The better measure of center would have been our median. And the reason being because of the outlier at 52. Now, something else that we hadn't really gotten a chance to discuss that I'll kind of throw in right now since we've got time and not a whole lot more to look at, is that we typically group these up into pairs. Is that typically the mean goes along with standard deviation, and typically the median goes along with interquartile range. So in this case, if we're saying that the median is better to use because of the outlier, that also means the interquartile range of 11 is better to use as well. So interquartile range equals 11 is the better measure of not center, but of spread. So remember that the standard deviation and interquartile range are measures of spread, so that would be the better measure of spread. All right, I believe that's all I've got for you. Quiz this week will be over everything we've talked about so far. So we'll talk about the intro to statistics, it'll talk about data displays, it'll talk about describing data and data displays, and it'll talk about what we did today with measures of center and spread. If you guys have any questions, make sure that you are stopping in during office hours or at least emailing me so I can work through those for you. And have a good day. I will talk to you next time.